Hello! So you may have noticed that I've stopped building the C64 Saver. It's been half a year or something since I made the last one. People are still coming to me and asking for savers. But I'm sorry, it's just too time consuming. I love doing them, but I had some problems that showed up late. And also I'm working now, so I don't have time for it. So what I did to fix it was to add a capacitor here, such that you don't get that voltage ramp when you plug in the cable or switch on the Commodore, because you have a long cable, power cable, and when the power is switched you get some bouncing on the switch, and then when 1 amperes comes and goes, the coil that is formed by the long cable will cause spikes. Actually, it's much more than that. You have capacitor in the C64, and when it's off they are empty, so when you switch it on it dumps a lot of current into here, like it could be up to 20 amps, and when it switches here it causes a lot of disruption in this current here. So also you can't just add a lot of capacitance here on the input of the circuit, because then you get something called an LC tank. So when you plug the cable into the Commodore or into the Saver, you get something that looks like this. And this voltage can be very high though. So, but there's some resistance in the cables, it's not that bad, and also I'm only using like 10 microfarad here, so it's not causing that much spike, it actually reduces it. So that's one problem you have, and the other one is when the switch is bouncing, what happens then is that the long cable, while there's a current going here, when the Saver sees that this switch is opened or is bouncing, actually when you turn it on it's actually bouncing on and off. This is 1 amperes. When you stop a current going through a coil, it wants to keep going because there's a magnetic field there. What happens instead is that the voltage just rises to sky limits. So not sky limits, but it does actually rise. So that's what the capacitor is for, that I have added to those who have gotten broken ones. So I fixed a couple of savers actually. Now I found this paper, and this circuit is not so different from mine. This is a Texas Instrument application report, and it's perfect because over voltage protection, and they use the same TL431. Yeah, so let's have a talk about that in this video. And also I want to do an open source project. It won't be as small, because I don't think the general public can make such a small device without short circuiting. sorry for saying that, but I'm sure you can do it if you have the skills, but not the general hobbyist. So no offense intended. So so here's the circuit that they have in this application report, and I really like some features, because I added a capacitor here to protect from those spikes coming from the long cable, and then I was thinking, okay, let's add a Zener diode here. That's a fire hazard, I think, because if you add a Zener diode here, what happens if that gets broken? Okay, then you get large current going through it. So what I've seen in the Savers that has been broken and I have fixed is that this TL431 and the signal transistor, mine is up here by the way, anyway, both of them are broken from spikes or hot swapping or something like that. So we need to protect this device even more. And what they do, instead of having the Zener diode here, they have it here and here. So what this does is that it limits the voltage that can rise over this a TL431 or LMV431, and it also limits the voltage that can go over here, over this signal transistor, and the voltage over this gate. So, but I haven't seen any broken MOSFETs yet, only these two, but it's a pain for me when that happens. So I really like this. And why doesn't this burn up? You already have a current limiting resistor here, so that's perfect. And you can see also you have current limiting on the other Zener diode on the top there. So if they go short, if they go broken, they won't cause a fire hazard. So that's perfect. Yes, I really like that. This is for automotive, so you can expect a project from me soon. I'm just playing around with optocouplers here because I was thinking, okay, if I make it open source, let's add some software control. So here's the idea, that we have a current and voltage measurement before we get the protection circuit. And if you have a microcontroller for software control, you don't really want it to reset and like stuff like that. So we need to protect it somehow. So I was thinking, okay, let's put it on the 9 volt. 9 volt AC. We have that on the Commodore 64. So let's just rectify it. It will only pull about a milliamp or two. Okay, so let's produce 5 volt from 9 volt. So if there's a fault, the microcontroller will still run. And the other thing is that I don't want software to control the protection directly. I want the protection circuit to be autonomous, because if something happens in the software control, so it resets or something, it still have this protection circuit. But what you can do is that if it shuts off power, you can have the software control keeping it off, right? So you can have a program. You can say the user can like tweak it with a. Anyway, here's my power supply. I will show this in another video. I have made videos about it. I just haven't released it yet. So I made this fugly display. I'm going to make it much prettier. So anyway, so they have like this, or just push buttons or whatever, and then they can like have a OLED display showing like, okay, so you want automatic reset if there's a fault triggered, or you can have latching. So the software can, like, if it sees if there's an over voltage, the software can help keep it low even when the voltage comes back down again. So we can have like a configuration thing going. Because there have been situations where power supplies have been like the the capacitor in the power supply is dry, and you get 50 hertz or 100 hertz out into the Commodore. Then you can see that in software, and you can keep it off even though it comes in and out like 100 times a second, the voltage level. So yeah, so. And also another thing, my friends like Mindflare Retro is fixing Commodore 64s, and also Mitchell Dayton, he also fixes Commodore 64s. And the thing is that when they use Saver for fixing Commodores, it works, but if there's an overcurrent situation, like for example a SID chip is broken, what happens is that the voltage in the 9 volt, so this is 9 volt AC, so the voltage in the 9 volt AC or the voltage out of the power supply for 5 volt, it drops. But what happens really is that when the voltage gets down to 2.5 or something like that, it doesn't drive this circuitry so well. So what can happen is that this one goes into liner mode, so it gets hot. So it has happened to Mindflare Retro's Saver, but it didn't break. But then I was thinking, okay, we have some current measurements. I do have a project here, by the way. Oh, I can show you. I can show you live on this. So I need 2 hands for this project. Let's see, like this. There. Haha. So these are 4 layers of Captain tapes. He has a YouTube channel or my Twitter post. It said I could use red tape, so you can do that also. But I've used Captain tape because when you add like 4 or 5 layers, it blocks out ambient light. Now I can shine light on it and still read the display. But without it, it sucks really bad. So, so yeah. So you can see, it kind of works. It gives you a higher contrast. Anyway, that's not what I'm going to say. So this is the current going through the ENA. Oh, this isn't working so well. The ENA. So this is ENA 219. It's a current measurement. And then it has I2 square bus, so it's connected to the Arduino. So you just take the 5 volt and then run it through it, and what you get is a voltage and current measurement with I2 square C. So and then the cool thing about that is just 2 IOs, and if you need galvanic separation or isolation between the 2 power supplies, you only have to isolate 2 wires. So this will increase the cost, but I was thinking we can make an open source saver that you only plug these components through whole components, and that's it. And then you have an input connector and output connector, and then you're done. Like great. Then we can also plug it in here into your Dewey power supply with like terminals like this block terminal. So you can make it like dual purpose. Then if you want to, you can actually add an INA, a OLED display, some buttons, and then yeah, all of this stuff up here, the microcontroller stuff. I have just shown it, like for example, if something happens on the gate here, this that means that this circuit is triggering the safety or the overvoltage. There's light going into an optocoupler into the MCU, which is isolated here. So yeah, so if there's overvoltage, this one has to tell this one it's actually overvoltage, and then you can sort of go the other way and shut this off again. I think I drew this down here. Yeah, so if there's a overvoltage, the circuit trips. What happens is that this one goes on. I think I've drawn it incorrectly, but yeah, I'm missing the transistor here. This one. So when it trips, it pulls this one down, and then this one pulls the gate off here. So, and when it pulls it up, it also pulls the opto isolator up, such that it turns on. So what I was thinking is that when this happens, it tells the microcontroller that okay, we have an overvoltage. Do you want to latch it? If it wants to latch it, depends on your configuration. It can actually do that here. So the microcontroller turns on another optocoupler and then switches it off. So it will be a lot of optocouplers, and then we also need some isolation for the I2 square C. But anyway, these are optional. So the display is optional, the INA is optional. I was thinking, so hopefully the board won't be too big. Yeah. So I hope you liked the video. Sorry for the shakiness, it's just an idea I have. I thought it was better to make just a waffle video, because it's really hard to get these videos out. Made the power supply. I'm having a lot of content for that. Just need to edit it. I have done some stuff with the microcontroller. I do also have another project coming up. I can show you. I'm spoiling you guys, am I? So this is a Nintendo nunchuck thing. So you can have wireless controllers on your Commodore 64, made by Turlan. So it's a project on Forum 64. So I bought this wireless, very inexpensive controllers. Now it's dead. There you go. You see it's blinking. It has this other one doesn't have batteries, I think. No. Yeah, this one has batteries. So, and then you have these. I dislike that he's using a custom connector for this because they are really hard to get. So I have bought these guys so you can stick them in there and then solder this onto here somehow. Just for now. So I was thinking maybe redesigning this board because this is open source, so I can actually do that. So you can repurpose here. We can like make a footprint like this and cut out around here so you can use both. I was thinking, I'm not sure. Yeah, I'm spoiling you now. I shouldn't show you this because it's a video coming up. Okay, thank you for watching. Bye bye.